This is Physical Science 2, Chapter 20, Part 3 on Earth Materials. In this portion of the video lecture, we will be discussing sedimentary rocks. The next branch of the rock family are the sedimentary rocks. These are the types of rocks that can form from either pieces of minerals or other rocks coming together, or be formed from either physical or chemical processes. So when we talk about sedimentary rocks, the surface material of Earth is going to help make up one type of sedimentary rock. We form these sedimentary rocks from clasts or pieces of other rock, because as rocks sit exposed at the surface, they are attacked by the weathering processes, erosion. So the wind, the rain, the ice gets in and attacks that rock and breaks it down into smaller and smaller pieces, perhaps transports that through water or ice to some other area. Rocks inside the earth are protected. So the only way that sedimentary rocks can form from other pieces of rocks is if those rocks get exposed at the surface by weathering or erosion. So weathering breaks the rock down into smaller and smaller and smaller clasts. We can tell a lot about the environment that certain types of sedimentary rocks were formed in because of the size of the clast and their shape. Jagged edges, rough edges, pointy edges would clue into a geologist that that environment where that sedimentary rock was formed was probably the same place where it was weathered or eroded. In the case of pieces of rock or clasts that are rounded and smoothed off, more than likely those clasts have had a little journey of transportation from one place to another, and so the bumping of other clasts on each other kind of slowly wears away those edges and smooths the surface. Porosity is what we call the empty space in between the grains of loose rock. So once we have weathering and erosion, we have essentially a pile of clasts. In order to get these clasts to form to a sedimentary rock, we're going to need to lessen that porosity. We're going to need to squeeze all of that airspace, that empty space, between the rock grains. So compaction is when, due to gravity, will pull material over the clast. So pressure will squeeze all of that pore space out. We still only have, however, a pile of tightly compacted rocks. We need to get those clasts to somehow stick together. Cementation is where oftentimes very mineral-rich water will act almost like a glue and keep all of these clasts together. So we can have certain types of rocks, sedimentary rocks, that form from compaction and cementation. These are the types of detrital sedimentary rocks. The word detritus in Latin kind of denotes waste or garbage. Not that these clasts are garbage, but they are pieces of other rocks. So the earth, of course, is a great recycler of all materials. So it takes those broken and weathered and eroded rocks, compacts them and cements them together to form detrital sedimentary rocks. And again, the size and the shape of those clasts can give clues about the environment at the time of rock formation. Very large clasts would indicate that an environment was pretty violent. For example, on the right side, or left side rather, here of your screen, you've got some roaring rapids. If water is flowing very fast, it can push heavier materials. On the right there, you have a nice stagnant creek. Only very small particles there would be able to be transported. So we can categorize our clasts based on size. Gravel is what we consider large clasts, anything that's over 2 millimeters in size. We can even go larger to cobble or boulder size clasts. But for our purposes here for sedimentary rocks, these are your basic 4 categories. So we'll consider gravel the largest clasts. Sand is kind of a medium-sized clast. Silt is a little bit smaller than sand. And clay is very, very fine clasts. Often with sedimentary rocks, because they are weathered and eroded and transported and deposited, most sedimentary rocks have minerals with a very high hardness level on the Mohs scale. And that's because they need to be resistant to scratching. So taking a look at classifying detrital sedimentary rocks, a conglomerate is a detrital sedimentary rock that's made with rounded gravel-sized pieces that have been compacted and cemented together. A breccia is very similar, except for the fact that the clasts here are very angular and jagged. Sandstone is commonly called enough, made out of sand clasts that have been compacted and cemented together. Siltstone is what we call silt-sized clasts compacted and cemented together. And the very smallest of the clasts will make up what's called a shale when we compact and cement those together. Another branch of the family sedimentary are the chemical sedimentary rocks. These rocks are classified by the chemical process that forms the rocks. When we talk about precipitation in science and in chemistry, precipitation is where you get a solid that will come out of a liquid solution. So precipitation is when excess minerals come out of their water solution because the water itself is so mineral rich, it eventually those minerals will start to solidify. A good example of a precipitate chemical sedimentary rock is what we call oolitic limestone. Oolitic, the prefix OO in Latin means egg. If you look at oolitic limestone, it kind of looks like a bunch of weird, hard little fish eggs that have been all compacted and cemented together. Oolitic limestone is when there's too much calcium carbonate in the water, and that comes out and precipitates to form oolitic limestone. Another chemical process is evaporation. So when dissolved minerals inside the water, once that water evaporates, it leaves those solid minerals behind. An example of an evaporite chemical sedimentary rock is what we call rock gypsum. This is when there's too much calcium sulfate in the water, and once that water goes away, calcium sulfate crystals are left behind. And the last branch of the family sedimentary rocks are the biochemical sedimentary rocks. Now, we have stated that both minerals and rocks are inorganic. However, we can, with biochemical sedimentary rocks, change over time from that inorganic, from their original form, to an organic form of a biochemical sedimentary rock. So these rocks have changed over time. Coquina is a good example of a biochemical sedimentary rock, often found along shores of lakes or rivers. Coquina is a very loose association of different shells and fossils from organisms. It's not very tightly compacted and cemented together. You could take a coquina and probably break it apart with the sheer force of your hands. But as long as those shells and fossils stay together, we consider that a biochemical sedimentary rock of coquina. Coal is a very important biochemical sedimentary rock that we mine for electricity purposes and power purposes. So coal is carbon from ancient plants and animals, again, that have turned from the organic carbon in the plants and the animals, over time has turned to the inorganic form of carbon, which again we can burn for our power sources. This has been Physical Science 2, Chapter 20, Part 3 on Earth Materials.